How are technologies shaping the future of architectural design? This project has convinced me that Unreal Engine is the perfect tool for presenting architectural solutions of any scale, offering virtually unlimited customization options to meet the client's needs. An impressive fact, this project contains almost 2 billion polygons and runs smoothly in real time at 3550 FPS in 4K resolution on an RTX 4090 GPU. The goal of the project was to quickly develop a land development concept and create an effective presentation. The interactive and immersive format was chosen as the most optimal way to showcase the design, allowing users to either explore the project independently or view it as a guided presentation. Thanks to pixel streaming technology, this project is accessible via a web browser on any device, making it incredibly flexible and convenient for all users. Just 1 month to complete this large-scale project. During the process, I conducted detailed conceptual land planning, calculated the technical and economic indicators, prepared 3D models, and created an interactive final product in Unreal Engine. For easy navigation within the project, I developed a simple and intuitive interface. With just one click, users can instantly move between key points of the site. When transitioning to a selected location, area information is automatically displayed and the camera moves smoothly, with the trajectory calculated automatically. All project controls are simplified to a minimum. Navigation is done using the left mouse button, while zooming in and out is handled by the mouse wheel. This approach makes interacting with the project straightforward and accessible for all users, regardless of the device they are using. Now let's dive into the technical aspects of this project. But before we begin, I'd like to recommend my training course, which will be useful for architects, designers, and visualizers. In this course, I provide a detailed step-by-step guide on how to create an interactive project in Unreal Engine 5. Link in the description. The project scene includes nearly 2 billion polygons, but to ensure high performance, most of the geometry is implemented using instance copies. For example, the outlet building complex consists of just 5 unique structures that have been duplicated using instance copies. This method significantly reduces the load on video memory by minimizing draw calls, as multiple copies of an object are processed as a single unit. The entire scene is built on the same principle. In the interior, instance copies are also extensively used for furniture, plants, and other objects, allowing for resource savings without compromising quality. The residential complex features a modular structure, where all the townhouses are composed of just 3 unique buildings that have been duplicated throughout the scene. Smaller objects, such as fences, are also built using instance copies, which helps optimize the rendering process and maintain high performance in the scene. I created the landscape of the scene using a mesh divided into 16 squares, with each square representing a high-resolution ground texture. I chose this approach because existing plugins for importing terrain directly into Unreal Engine did not provide the level of detail I wanted to achieve. To obtain ultra-high quality ground texture images, I used SAS Planet. This free application allows for easy export of selected map fragments from Google Maps and other sources in just a few clicks, breaking them into individual pieces at the required resolution. After editing these images in Photoshop, I created 16 textures with an 8K resolution. Next, I generated normal maps and a height map, which I used to create uneven terrain, giving the landscape more realism and depth. This method allowed me to achieve detailed and high-quality landscape visualization without sacrificing performance. Now let's move on to the foliage. To optimize the scene's performance, I reduced the variation in foliage. Only 9 unique, highly detailed assets from the Megascans library were used throughout the entire scene. Thousands of trees were duplicated using the foliage tool. Despite the large scale, all the vegetation in the scene takes about 5 milliseconds of processing time, equivalent to 10 FPS, an acceptable value for this project considering that over 6,000 high polygon trees are rendered in real time. One of the key optimizations for improving performance was changing the shadow cache invalidation behavior setting for the foliage from auto to rigid. This adjustment allowed me to gain around 5 FPS without any loss in visual quality, which is a significant improvement. since the user's primary view will be from a considerable distance from the ground, to avoid the repetitive texture effect on asphalt and grass and give them a more natural appearance, I developed a custom fade material. This material smoothly transitions the grass and asphalt textures to more appropriate versions for distant views as the camera moves away. The texture swap is handled by the camera depth fade node, which blends the foreground and background textures through the lerp node, creating a smooth transition and eliminating harsh boundaries between levels of detail. To create a photorealistic sky, I used an 8K HDRI map applied to a large diameter sphere. This added a realistic atmosphere to the scene, with a deep sky and natural lighting. As for the lighting settings, I kept the default lumen settings in the post-process volume, making only minor color corrections to achieve the desired visual effect. This approach allowed me to strike a balance between realistic lighting and overall color harmony within the scene. To resolve the issue of shadows disappearing at long distances, I increased the dynamic shadow distance movable light parameter in the light source, directional light, to 50,000. This adjustment ensured that shadows remained sharp even at significant distances from the camera. In this way, I achieved optimal performance and quality for this project. I hope the information presented in this video was helpful. Thank you for watching and see you in future projects.